My name is Tom Webster, and I'm an associate professor here in the Division of Engineering and the Department of Orthopedics at Brown University. So I became interested in engineering when I was an undergraduate, and I was completing a research project to develop a portable kidney dialysis machine, which was basically involved making a portable device that fits on your belt buckle. What I'm doing now is basically using nanotechnology to create better structures for buildings, for implants, and for medicine.
My name is Karen Haberstroh, and I'm a faculty member in the Division of Engineering here at Brown University. And I'm also the director of STEM outreach, so a lot of the work that I do at Brown is in partnership with the Providence Public Schools. I first became interested in engineering when I was a student in high school. We were fortunate to have a faculty member come in from engineering at Northeastern to talk to us about engineering in general and their program. Before that point in time, I really had not heard of engineering and didn't know what engineering was all about. And it seemed like it would be a really good match for the type of design and math and science skills that I had a lot of interest in.
Hi, I'm Chris Bull. I teach engineering at Brown University. I've been an engineer for about 30 years, and it's curious because I came to school to study music. But one of the things I did was work in a lab where people were doing engineering, and I got hooked on it. There were a couple reasons. One is that I like making things, and engineering is certainly an opportunity to turn ideas into reality. The other is it showed me that there was an opportunity to be creative and to solve problems that face people all over the world. My research is focused on material science and renewable energy. My part of this course will focus on the physics that sort of back up wind energy and how we translate that energy that's in the wind to the electricity that comes out of the socket. So we'll look at turbine design, the design of blades, the guts of what's behind it, so generators and gearboxes, and then at how we actually deliver that energy to the end user.
So the particular part of the course that I'll be focused on has to do with designing a replacement for the heart. And the reason that we care so much about this as biomedical engineers and as tissue engineers is because there's such a shortage of donors across the country. So in this particular part of the course, you'll have the ability to look at the different material choices, whether we should consider synthetic materials or natural materials. We'll think about stem cells as well, which is a new field of engineering right now. And again, ultimately, the design projects that we go through, these mini design steps, will bring us to this ultimate final design.
So in my part of the course, we will use nanotechnology to create an elevator that goes from the Earth to the Moon. And this is important to decrease costs associated with space travel, to reduce the energy that's needed to get space shuttles up into orbit, and to just learn more about space in general. So students in the course will learn fundamental knowledge of how to build structures, fundamental engineering principle. We'll also learn about nanotechnology and what it means to have nanomaterials with improved properties to make structures, and ultimately we'll understand the future of technology and how to create this elevator from the Earth to the Moon.